All right, section 7.1, our task is to figure out how we can find the area between two curves. So I drew this picture for you to show you what that might look like. Keep in mind, we did learn already that to find the area under a curve, we would use an integral for that, right? So if I took the area or the antiderivative from A to B, because that's the interval value given here, for just f of x, that would give me all of this green space plus this space down here, okay, plus this space down here. If I were to take the antiderivative from a to b for g of x, that would give me the area under this curve down here, these red lines that I just drew. So geometrically, if I wanted to just find the area that goes between these two curves, all we would have to do is take the area under F and subtract the area under G, and you would have your solution. Okay, so it's going to look like from A to B, the area under f of x minus the area under g of x. You can put it in one integral rather than separating into two different ones. And that's basically it, okay? Let's take a look at what an example might look like. So find the area of the region bounded above by y equals e to the x, so that's the top curve, and below by y equals x, that's the bottom curve, and bounded on the sides by x equals 0 and x equals 1. Okay, so when you set up your antiderivative, your area expression, remember the interval values are going to represent where you begin and end on the x-axis. So these are x values, okay? These are x values, 0 and 1. Maybe make a little note of that. And then inside the integral will be the equations, but you have to make sure you do the top graph, the top curve, minus the bottom curve when you are setting this up. So it's going to be e to the x is the top curve minus x. And then dx is just that command to say that we are working with the letter x in our computation. Now you would simply antiderive. So the antiderivative of e to the x is e to the x. The antiderivative of x would be 1/2 x squared. And we're plugging in x values of 0 and 1. So there's your 1 plugged in to each equation minus 0 plugged in. And compute. So e minus 1/2 minus e to the 0 is 1. And then all this would be 0. So this would be your answer. I think I'll just combine like terms and call that negative 3/2 or negative 1.5. So this is your area computation. Okay, let's try another one. So for this question, it says, find the area of the region enclosed by the parabolas y equals x squared and 2x minus x squared. Okay, so I want to start with the fact that the graphs will not be given in a question like this. So I went ahead and drew x squared, and I went ahead and made a very rough sketch of what I think 2x minus x squared looks like as a graph. I just want to clarify, I don't know exactly what this line, this 2x minus x squared looks like. I just needed a rough estimate. So what I did is I knew right here that a negative in front of the x squared term would make that parabola flip upside down. And then I just picked a couple of x values to plug in to find some coordinates. Like I plugged in x equals 0 and got 0. So I knew it had a point at 0, 0. I plugged in 1 and got 1, so I knew there was a point at 1, 1. And that was basically all I needed. So just to clarify, in the directions, it says find the area enclosed by the two parabolas. So that would be all this green space here. Okay, to set up your antiderivative, you need to see what x value to what x value that area kind of encompasses. So it goes from x equals 0 to x equals 1. And then remember, it's like top curve minus bottom curve. So the top curve is the blue one, and the blue one is the 2x minus x squared minus the bottom curve, which is x squared dx. I'm not going to integrate yet. I think I'm going to go into this function I created and combine like terms. So I would make that 2x minus 2x squared. And now I can antiderive. So antiderivative would be 2x squared divided by 2. And this would be 2x to the third divided by 3. And we are evaluating from 0 to 1 on the x-axis. I'm going to get rid of these 2's. I don't need them. So I'm going to plug in 1. And then I'm going to plug in 0. And we're going to solve. So we would have 1 minus 2/3. This is 0. This is 0. So 1 minus 2/3 is equal to 1/3. Okay, what might actually happen is you may be asked to find the area between curves, but the curves are kind of rotated. So they're not positioned in a way where you can find the area from the top to the bottom, but it's kind of drawn in a way where you would need to find the area from side to side, okay? So rather than kind of writing everything in terms of x values, in a situation like this, we would write everything in terms of y values, because our graph kind of goes from left to right rather than top to bottom. Let me show you what I mean. Look at this one. So this graph, I can't say which curve is necessarily on the top and which one's on the bottom when you're looking over in this region, okay? So I can't say, oh, the black line is always on the top and the blue line's always on the bottom. Well, not right here, right? Not in this area. The black line is actually on the top and on the bottom in this area. So it's just a little unclear. What I can say is that the black line is always to the left of the blue line. So we can kind of shift our integral and the way we set it up by doing a couple things. Okay, this is not always going to be something you do, but I do want you to understand this technique just in case. Okay, so instead of looking from left to right on the x-axis as far as finding starting and stopping points, we will look from bottom to top on the y-axis. So I can tell that my two graphs intersect when when y is -2, and they also intersect when y is 4. So I'm going to use -2 to 4 as my y values in my integral. And then when I set up the equations, now this is important, guys, listen. When I set up my equations, I need to keep in mind that these numbers I wrote, these are y values, okay? So when I write my equations, I also have to use y values. And this is not traditional because we are used to equations being written in terms of x. In this setup, I will have to write my equations in terms of y instead. So that simply means rearranging the equations to get x alone. That way you have your equation in terms of y variables. Now that's already been done for you if you look right here. It says XL, that just means the left graph. XR means the right graph. They've already gone ahead and taken these equations from up here and solved them for x, which is very helpful. So we're going to use that. And what we're going to do is we're going to take the right side minus the left side because we want the positive number minus the negative number, okay? So it's going to be the right side is y plus 1 minus the left side. And then this time, since we're using the letter y, it will be dy. Okay? I honestly think that's the hardest part right there because the rest is basically you just doing some algebra and integrating and plugging in numbers, okay? So right now what I'm doing is just running this negative through so that I can combine like terms. I don't feel like integrating this many terms if I don't have to. So I'm going to condense it down as much as I can before I anti-derive. So this looks like it's the best I can do as far as simplifying goes. So we're going to anti-derive now. Antiderivative of y, that's 1/2 y squared. Antiderivative of y squared, that would be y to the third over 3. And antiderivative of 4 would be 4y. And we are evaluating from -2 on the y-axis to 4 on the y-axis. Let's keep going. I think we can clean this up a bit before we plug in. So this is 1/2 y squared minus 1/6 y to the third plus 4y. And now we're ready to plug in numbers. First thing I'm doing is plugging in the number 4 all the way through. And then I'm going to subtract. And I'm going to go back and plug in -2 everywhere that I see a y. Okay, now we can go through and simplify. So we just need to be super careful. Looks like this is going to be 16 times half, that's 8. Then we have 64 times 1/6. I'll just call it 64 over 6 for right now. Plus 16. In this part, I've got 4 times half is 2, but there's a minus, so -2. This would be -8 times -1/6. That's positive, but the negative in front makes it negative. And I'm just going to keep it 8 over 6 for now. And this is -8, but the negative in front all the way over here makes it a plus 8. Okay, let's add all the whole numbers together. So we have 8 plus 16, that's 24. Minus 2 is 22 plus 8, I think that's 30. And the fractions have a common denominator, so you can add the tops together and you get 76 or 72 over 6. And 72 over 6 is actually 12. So the answer looks like it's going to be 18 units. Okay, let's take a second look at that last problem. What you could have done is you could have computed this by putting the region into 2 parts. But obviously, it's a lot more messy. So what I mean is I could have said, all right, let me find the area of all this space and get that total. And then I can find the area of all this space and get that total and then add them together. Okay? So I know that this concept of kind of turning things, rotating the graphs and looking at them in terms of y instead of x is a little confusing at first. But I promise you, if you had not done that, splitting the graph into 2 sections and doing it this way would have been double the amount of work. Okay, that's it. So Delta Math is your homework assignment. It's a pretty short assignment. I think it's about 6 questions. So you can get started on that and just let me know if you have any questions.